Dear students, welcome to my YouTube channel PCM Academy, and we have discussed the topics for IIT JAM Physics. Okay, and this is basically a crash course, so just I am telling the formula only, and the concepts also I will tell little bit of. And in the last class I have discussed about various coordinate system and the velocity and acceleration in various coordinate system, basically something like polar coordinate system, velocity and acceleration in polar coordinate system, in cylindrical coordinate system, and in spherical coordinate system. So now let me tell you some basic concepts of mechanics, something like Newton's law of motion and its application, and it is according to your syllabus. I am discussing the topics according to your JAM syllabus. Okay, if you see the syllabus, there is a topic that is Newton's law of motion and its applications, and this is the concept of just for your 11th level. Okay, so this is +2 concept. So you know this, but let me tell you again so that you can revise the concepts. So this class will be very familiar for you, and obviously mechanics, for mechanics most of the parts of mechanics is actually your 10+2 level syllabus, something like central force or moving coordinate system, and these are the course for your BSc honors. But basics mechanics, that will be for your just for the syllabus. In the syllabus of basic mechanics is just your 10+2 level syllabus. Okay, so let me tell you first about the concept of force. So what is a force? Force is just a push or pull which change the state of motion of the object. So this force is just a push or pull, you can say this is just a push or pull which change the state of motion of the object, state of motion of any object. And now mathematically, if you talk about state of motion, then the state of motion is described by velocity vector v. So if v is 0, then we can tell the state of motion is rest, and if v have some velocity, then it is in motion. Okay, so state of motion is basically described by the velocity vector v. And you know this velocity vector have two parts, obviously. One is its magnitude and another one is its direction. So if you give push or pull object, suppose we have an object something like this. So suppose we have an object of mass m. Okay, so if you give a push or pull, then if this velocity vector change, that means either its magnitude change or its direction change, then we can say that force is acting on this system or on this object. So it may be the change, maybe the change of direction, or maybe the change of magnitude. Okay, so suppose we have an object, and this object already have a state of motion something like v. Suppose it is in motion, or if v is equal to 0, then we can say it is in rest. Okay, so if its state of motion is v, now if you apply force, so you can apply force along this direction or along this direction, any direction. So there will be an angle between f and v, you can say. Okay, so maybe it is parallel to v, the f may be parallel to v, maybe anti-parallel to v, maybe perpendicular to v, maybe at any general angle. So according to that situation, that is the angle between f and v, the trajectory of this motion, the path of the motions will be different, and there are various paths of this motion according to the angle between velocity and force. So that I will discuss now. Okay, so there are various kinds of trajectory of motion. So let us tell you about the trajectory of motion. So there are different kinds of case. So let me tell you one by one. So case 1, suppose we have. So in case 1, if f is parallel to v or anti-parallel to v. So if f is suppose parallel to v, or you can say f is anti-parallel to v. Okay, that means the angle between f and v, theta is 0 degree here, and the angle between f and v is 180 degree here. Okay, so suppose we have an object something like this. Again, let me draw the same picture. So suppose we have an object of mass m, and the only force that is acting on this system is f, and v is its initial state of motion, and a force is acting along this line, along velocity vector v, that means F is parallel to v, and you can see this force can change only the magnitude of v, not the direction. So direction will remain same. This force that is acting parallel to v will change only the magnitude of v. So its direction will not be changed. So the path of this object will obviously be straight line. So here the trajectory of motion, you can say it will be straight line, just it will be straight line, it will be straight line. But if you have anti-parallel, then the same thing will happen. Here the magnitude of the velocity is increasing, but if the force is acting in reverse direction, that is along this direction, or you can write it in this way. So if theta is 180 degree, that is force is anti-parallel to v, then also the path of the motion, the direction of the object will, the direction of the motion will not be changed, because it will only decrease the velocity. Here the velocity is increasing and here the velocity is decreasing. So the path will be same and the path will be straight line. And the path will be straight line. And please remember, here when we talk about force F, so all other forces are absent, we assume here. So we assume only force F is acting on the system. There is no other forces acting on the system. If there are other forces acting on the system, then the path will be maybe changed. Okay, so when F is perpendicular parallel to v or F is anti-parallel to v, that means only the force present in the system is F. So please remember this thing. And case 2, let me tell you about if F is perpendicular to v. Okay, so case 2 we can discuss that F is perpendicular to v. That means the angle between F and v is just 90 degree. So what kind of motions will be there if F is perpendicular to v? And when you talk about F is perpendicular to v, that means the angle between force and velocity always is 90 degree. It is not like that if you give the force initially at 90 degree, then you release the object. This kinds of thing is not happening here. You have to give the force continuously to this object such a way that the angle between F and v is always 90 degree. So what kinds of motion you can get here? So there will be always circular motion. So the path of this motion, the trajectory of the motion is always will be circular, because you know in circular motion only this is happening. So if we have a circular motion, then the direction of the velocity is always along tangent, and the force that is required to move this particle along this line is centripetal force, and that is acting towards the center. So you can see the angle between F and B will always be 90 degree. Suppose here if the velocity is along this direction, then force is along this direction. Similarly here, if velocity is along this direction, force is along this direction. So each and every point, in each and every point, your velocity vector will be perpendicular to force, and that is the trajectory of motion will be circular. And the last case that you need to know about, if there is any angle between F and V. So we'll talk about case 3. So any general angle between, that is any general angle between F and V. Any general angle between F and V. Okay, so that is theta, let me see. So now again let me draw the same diagram. So the object of mass m, suppose, and a force is acting with the velocity vector v at an angle theta, suppose this. Okay, now if you resolve this force into two components, then you can understand. If you resolve this force into two components, suppose one will be along this direction and another will be along this velocity vector. So this will be f sin theta, this will be f sin theta, and this will be f cos theta. This will be f cos theta. Okay, so you can see where f cos theta is parallel to v and f sin theta is perpendicular to v. Okay, So if cos theta try to pull the object along straight line, but if sin theta will try to pull the object along circle, because if sin theta is perpendicular to V, so that will be similar to case 2, and if cos theta is parallel to V, so that will be similar to case 1. So two cases is simultaneously present here. That's why if cos theta will try to pull the object along straight line motion, but if sin theta try to rotate the object along the circular path. Okay, so the combined motions will be just like helical, something like this. Okay, so the combined motion will be something like this. Okay, so something like this. So that will be helical path. So here the trajectory will be helical. Okay, so please remember this kinds of trajectory of motion, that will be very helpful. Sometimes MCQ questions, 1-mark questions may be asked from this concept. Okay, so now let me tell you about the various kinds of force. Okay, and one of the important force is normal reaction. So if you talk about force, okay, so if you talk about force, then force can be categorized into two category initially in mechanics. Actually, if you talk about the fundamental interaction, then there are 4 fundamental interaction, you know, and that is actually the topic of modern physics. I am not going to that detail here. That there are 4 kinds of interaction, something like gravitational interaction, electromagnetic interaction, weak interaction, strong interaction. So that will be the part of the particle physics, actually based on the particle exchange between the objects. The forces can be categorized, but that is the universal categorization of force. You can say that independent of any criteria, you can say that the force, there are 4 type of interactions in universe or in nature. But here in mechanics, we encounter with 2 kinds of force. One is contact force and another is non-contact force. And obviously that forces will also be either one or in the other category of that kinds of 4 kinds of interactions. Okay, so if you talk about in mechanics, various kinds of force we will study here, but that forces will also be the category of any kinds of 4 fundamental interaction. Maybe it is electromagnetic interaction, maybe it is gravitational interaction. So we will see. So mainly here we will study about the gravitational interaction and the you can say that the electromagnetic interaction, because this is not the discussion of modern physics or particle physics. This is mechanics. So in mechanics we will encounter with 2 kinds of force. So one is, you can say, contact force, okay, and another is, you can say, non-contact force. Again, this non-contact force we will not study here, okay, because non-contact force means, you can say, the gravitational force is also one kind of non-contact force, gravitational force. So we will study in separate chapter with central force motion. Okay, and the second thing is that obviously the electromagnetic force or the electrostatics force, even force between 2 charged particle maybe. So electrostatics force or electromagnetic force, you can see electrostatics force or electromagnetic force, something like this, when 2 charged particles are away from each other at a distance r, q1, q2. So you know Coulomb force, you can say, okay, or gravitational force, you can say Newton's law of gravitation instead of charge if you talk about a mass. Okay, but we will not discuss this kind of thing because we have different section of physics to discuss this. Here in mechanics we will deal with these contact forces, and contact forces are something like normal reaction, okay, normal reaction. It will be tensional force, this is very important, tensional force, okay, and we have spring force also. We will discuss spring force, and that is different. We will discuss this in different section in oscillation, and we will discuss in the chapter work per energy also. Okay, and frictional force we will discuss also in this section. Okay, so these are just contact force. This force will acting only when 2 objects contact with each other. then only these kinds of forces will be arised. But this can be arised without contact between two objects. Okay, so let me discuss these forces one by one. That will be very helpful for problem solving purpose in your basic mechanics. Okay, so let me first start with the normal reaction. Okay, so what is normal reaction? If you put a object on a floor, suppose this is a contact force, so obviously this force will only arise when two objects contact with each other, and at each and every point of contact it will arise. So suppose we have an object something like this of mass m. Okay, so when this object will contact with this floor, what will happen here? So this object will give a force to the floor, and the floor will react with the same force, and that reaction force, which is normal to this plane, is actually the normal reaction. Okay, so normal reaction is always perpendicular to the surface, contact surface, and it will arise at each and every point of contact. Here also there is normal reaction, here also normal reaction, here also normal reaction, but this is actually the resultant. What we will show in picture is the resultant actually. So contact force will act or will arise at each and every point. Okay, so what is, you can write here that what is, if you talk about what is a normal reaction, so normal reaction is the reaction force which is actually normal to the contact surface. So it is a reaction force, which acting normal to the surface, Okay, and the second thing is it will act at each and every point of contact. It will act at every point of contact. Okay, and the third point is that it is not necessary always that the normal reaction will act along center of gravity or along center of mass. So it is not necessary always that it will act to the middle of the object. Okay, so it may or may not be passing through the center of mass. So normal reaction may or may not passing through the center of mass. Something like we have this kinds of picture. If we have this kinds of situation, suppose these are walls. Okay, and let us put object something like this. Suppose this is object. So what you can see, so this is the center of gravity. So center of gravity or center of mass you can say, but at this point the normal reaction will be perpendicular to the floor here. At this point the normal reaction will be perpendicular to it. Okay, so it will be perpendicular to the contact surface, but it is not necessary always that it will pass through the center of the object or the center of mass of the object. Okay, but sometimes what will happen, you can't find the perpendicular to the surface. So if that situation is happening, if you can't find the perpendicular to the surface, but if you find the perpendicular to the object, then you can write the normal reaction perpendicular to the object also, something like this. So if you can't find perpendicular to the surface, then draw perpendicular to the object, So let me tell you how. Suppose the same thing, if this is happening something like this, so your object will be something like this. Okay, so what will happen? You can find the perpendicular to the contact surface here, that will be known, but you can't find the perpendicular to the surface here. But you can find the perpendicular to the object, because this is the object of the surface of the object. So you can write normal direction something like this. So this is perpendicular to the object. So when you can't find the perpendicular to the contact surface, you should draw the normal direction perpendicular to the object. But if you can't find both perpendicular to the surface or perpendicular to the perpendicular to contact surface or the perpendicular to the object, if you can't find both, then you have to resolve the normal direction into two components, something like this. So let me tell you here. Suppose we have this is suppose object, and a triangular shape object is here. Suppose this is a wedge, something like this, and we have to find out suppose normal direction at this point. So you can't find both perpendicular to the surface or perpendicular to the contact surface. Okay, so what you have to do here in that case, you have to resolve into two components. So one is nx and another is ny. So obviously finally when you solve the problem, you will get n, and that will be square root of nx square plus ny square, and the normal direction will be along something like this direction, and at which angle you can also find out by using tan theta will be ny by nx. So you can find, but this is very complicated case. This will arise in very complicated case. Okay, now if you have the round shape object, okay, suppose you have a spherical kinds of object, something like this. Suppose you have spherical object, and the normal direction will be always passing through the center of this object. Suppose this is your contact surface, and the normal direction will always be perpendicular to this surface, and in that case it will pass through the center. Okay, so for round shape object it will always pass through the center. But if you have something like, suppose if you have a object which is rolling on a surface, so this is rolling on a surface, and you have a obstacle something like this. Okay, now what will be the normal direction at that contact point? What will be the normal direction at this point? So in that case you have to draw a tangent at this point, and the normal direction will be perpendicular to this tangent, that will be along this direction, and that will also be passing through the center of mass, or you can say the center of this spherical object. Okay, and the most important thing, that this is a contact force. The basic thing is that the normal direction is basically a contact force. So whenever any object loses contact, okay, detach from this surface, whenever any object detach from its contact surface, the normal reaction will immediately be 0. Okay, as soon as it will left the surface, or it will leave the surface, the normal reaction will be 0 immediately. Something like in the case of lift, you can see. Okay, so when the lift is moving, suppose in downward direction with acceleration g, then you know there will be no normal reaction on this object. So we will see later on also this thing, and I think you know this is your 10+2 level syllabus just. Okay, so you know, so if the lift is moving downward, then normal direction is 0, that means it will lose its contact with the lift. Okay, similarly, suppose you have a bubble shape like path, this kinds of hemispherical bubble shape path, and we have an object over here. Okay, so if there is contact, so obviously two forces are there, one is N and another is mg. But if you push it, so it will be rolling along the surface, and suppose it will left its path, something like this. So when it will leave the surface, at which point it will leave the surface, immediately the normal direction will be 0. the normal reaction is 0. So this condition we will use for problem solving purpose. Okay, sometimes questions are asked that at which distance from the top it will leave the surface. So the condition will be at that point n is equal to 0, because whenever it will leave the surface, the normal reaction will immediately be 0. Okay, so please remember this points about normal reaction. Okay, now let me tell you about the tensional force. This is also one of the contact force, and please remember this normal reaction is actually electromagnetic in nature. So that I have told you earlier that there are 4 kinds of interaction. One is electromagnetic interaction, another is gravitational interaction, and another is weak interaction, and another is strong interaction. So whatever force you can remember, whatever force you can tell, they will lie any one of this category. So this normal reaction is a class of electromagnetic interaction. Why? Because this is arise completely due to the region of this force between this molecular the molecules of these surfaces. So the molecules of these 2 surfaces, so they will actually originate this force normal reaction. So by origin you can say this normal reaction is also electromagnetic in nature. Similarly, this tensional force is also electromagnetic in nature. Why? You can say that suppose we have a rope. Let me tell you with an example. Suppose we have a rope, something like this. We have a supports. Here also one support we have, and we have a support here also. A rope is suppose bound in this way. So if the rope is just in this way, so this is loose, so the rope is in. So if you touch here, you will say that it is loose. Okay, but if you bind in this way tightly, okay, then you can say this is very tight. If you touch this rope, you will say that it is very tight, and that tightness, this tightness in physics is actually the tensional force. So whenever the rope is in tight, okay, state, then you can say that the tensional force will arise here. But when it is loose, so no tensional force will arise. Why? This is because when you tight the rope, then its molecules, the molecular force will arise. So these molecules want to separate. So intermolecular force of attraction will arise here, and that force, this intermolecular internal force, is actually the tensional force. This is denoted by T. So you can see the by origin, this tensional force is also electromagnetic in nature. This is also electromagnetic in nature, because by origin this is just a molecular force. Now the next question is, what will be the direction of this tensional force? This is very important. So you can see always the tensional force will be away from the point where you want to find out the tensional force. Suppose if you want to find out the tensional force here, so you can see that this rope will pull this support, so the tensional force will be along this direction. So here also the rope will pull the support, so the tensional direction will be along this direction. So always tensional force will away from the object. Suppose we have an object something like this, and we have a string, and if you pull the object by this string, then obviously the tensional force will be along this direction. So tensional force will always be away from the object. This is because we can't push our object by using a rope. We have to always pull the object. You can't push the object along this direction. So tensional force will never be towards the object. It will always be away from the object. And if you have two objects, suppose we have an object something like here M, and another object is suppose M dash, and we have another object suppose M double dash. So if the tensional force here is T, then the tensional force here will be different, that is T dash. So for different rope or for different string which are separated by a mass, the tensional force will be different. But if the string is massless, ideally this is very light mass if you talk about. So if this is massless, then tensional force throughout the string will be same. But if it is a mass, then the tensional force at each and every point will be different. So please remember this thing. So whenever we talk about the tensional force throughout the string is same, that means this string is taken as massless approximately, because this is very low mass compared to the object that is connected with this rope. Okay, so comparison to this mass of this object, the mass of the string is negligible. So that's why we can tell sometimes that this is a massless string. Okay, similarly we will see some mass pulley system. So this is a very popular problem, you know, mass pulley system, and tensional force will be arise there also. So in mass pulley system you can see sometimes this kinds of situation. Suppose we have a pulley and we have two mass M1 and M2. This is M1 and this is M2. Now you can see what is the tensional force at this point. This point tensional force will be away from the object, so T, and this point it will also be away from the object, so it will be T. But this 2T will be same if and only if this string is massless, the pulley is massless, and there is no friction between the pulley and the string. So the pulley should be massless and frictionless pulley. Massless and frictionless pulley. And frictionless. Then only the tensional force on both sides of this pulley will be same. Otherwise it will be different. And most of the cases we will discuss in Newton's law basically, that this pulley is massless and frictionless, and the string is light, and obviously light string and inextensible string. So string should be inextensible. Otherwise tensional force will be changed. So these are the conditions you should know for problem solving when you talk about when you have to identify the force on each and every object in a system. Then you should know the property of this force. And in Newton's law, most of the problems can be solved by using only these two forces, that is tensional force and the normal reaction. Okay, and the other forces we will discuss in separate chapter. But here we will tell you in the next class how you can use this force to solve a problem, how you can draw the free body diagram, and how you can apply this by using Newton's second law. Okay, so for today, thank you.